Good afternoon. So we may start our tutorial now. So this group, we have not complete some questions. So here we go. Question 1.
Tutorial 3. Question number 1. A. Let x be a random variable that represents the gamma distribution with a shape parameter alpha and a scale parameter theta. Suppose the distribution x has an independent samples of x1, x2, x3 until xn. Prove by the method of moments that the estimate of theta is given by this formula and the estimate of alpha is given by another formula. So, given that x is gamma distributed with the parameters alpha and theta, if the distribution x has an independent samples of x1 until xn, so we try to use these samples to estimate the theta and alpha as well. Solution for 1a. Since the distribution x has an independent samples of x1, x2, x3 until xn, therefore the sample moment gives where the first row moment is equal to the summation of x from the samples divided by the total sample size, which is n, and the second row moment, which is equal to the summation of the sample square divided by the sample size, which is n. Now, if x is gamma distributed with these parameters alpha and theta, therefore from table C, we will have the first row moment and the second row moment. That is these two. So from the second row moment, we can rearrange. This becomes alpha times theta square n plus alpha times theta n times theta. And next, I'm going to substitute this alpha theta, which is equal to the expected of x, that is this. So I will have 1 over n multiply the summation of xi, where the I take from 1 to n square, and plus. So again, this alpha theta, which is the expected of x, and which is equals to this. So I will have 1 over n multiply the summation of xi, where I takes from 1 to n, and multiply the theta. And of course, this is the second row moment, which is equal to this. So the left-hand side, which is equals to the 1 over n, multiply the summation of xi square, where I is taken from 1 to n. So this theta will be equal to this minus this and divided by this. So therefore, we found the theta, which is equals to this result, minus this, and square, divided by this result. So if we simplify this, we will have this divided by this is become summation of xi square divided by summation of xi, and minus this square divided by this is become 1 over n, and multiply the summation of xi. And therefore, this is our estimate of theta, and we prove the result. And next, we try to prove the estimate of alpha. So from here, we know that the expected value of x, which is equal to this, therefore this will give me 1 over n multiply the summation of xi, where I takes from 1 to n, and which is equals to the alpha times theta. So alpha times this result instead of this, so we will have the summation of xi squared divided by n minus 1 over n multiply the summation of x squared and divided by 1 over n multiply the summation of xi. And next, we can simplify this, that this will be multiplied here, so alpha will equal to 1 over n multiply the summation of xi squared and divided by this and this can be simplified and left the summation of xi squared and divided by n multiply summation of xi squared summation of xi squared. So this is our estimate of alpha, and we prove the result.
Okay, class, to prove this quite easy. Only the trick is here that you must know how to, from this gamma second row moment, that I expand into here so that I can straight away expected value of x. Okay, so where my expected value of x is given, that is here, right? So I'm going to substitute the whole thing alpha theta as this inside here. So this is a trick here. So that straight away I can calculate the theta. And after that, once you have data, of course, no problem, we can get the alpha. Okay. And now we move to the application in second part.
Part B. Suppose the following sample of lot sizes follow a gamma distribution, which is given by these samples. By using the method of moment, estimate its parameters. So from part A, the result we have found, we try to get the sample moments of the summation of x and also the summation of x squared from this data, and we substitute inside these two formula from part A, then we can estimate the parameters of theta and alpha. Part B. Let x be the loss random variable such that x is gamma distributed with the parameters alpha and theta. Then from the given samples, we have to find the summation of x and also the summation of x squared from the sample. So we will have the summation of this sample.
Okay, class, I think this is a very simple calculation. Do not waste your time. Okay, you have to calculate the summation of x and also summation of x squared from the data. Okay, after that you just put inside to this alpha and theta, you will get the result. Okay, so once you have the formula, you just try to calculate the summation of x squared into the formula. Okay, so do not waste your time. So this is very simple calculation. Okay, so we move to question 2.
Number 2. Summary statistics for a sample of 100 losses are given as follows. So we have intervals, number of losses, sum of the data from the intervals, and sum square of the data from the intervals as well. And the total is given by this. A Pareto distribution is fit to this data using the method of moments. Determine the parameters estimates. So we let the X is Pareto distributed with the parameter alpha and theta. So we need to estimate these two parameters by using the method of moment. So that means we have to calculate the first row moment and the second row moment from the informations here. Solution for number 2. Let X be the loss random variable such that X is Pareto distributed with the parameters alpha and theta. Then from table C, we have the first row moment and the second row moment in terms of theta and alpha. But from the sample moment, we have the first row moment, which is equals to 1 over n, and multiply the summation of the xi. And this is given by the questions, which is this figure. And this will give me 6677.54. Now similarly, for the second row moment, we will have 1 over 100 and multiply the summation of x squared, where I takes from 1 to 100. And the question is given that the summation of x squared, which is this figure, so we have.
Okay, class here on the highlight, you no need to calculate the sum because it's already given. Okay, this question they put like that, they just want to confuse you. Okay, so we have some data in the first interval, some data in the second interval. So the sum up is the individual group will give this sum, but the total sum is already given. Okay, that is the summation of x. This is summation of x squared. Okay, not the average, okay, this is just a summation only, okay. So
this figure, so we have and this will give me
so that's I want to highlight here. Some students they treat the expected x is this value. That's wrong. You need to divide the 100 because the information given is only the summation. Okay, not the average. Here also the same. The information given is the summation of x squared. That is this. Okay, you have to divide the 100, please, because the question is not give you the expected for the first row moment or second row moment. Okay.
So therefore, the data divided by alpha minus 1, which is equal to 6677.54. Say this is first equation. And this second row moment will be equal to this. Therefore, 2 data squared divided by alpha minus 1 and alpha minus 2, which is equals to this figure. Say this is the second equation. And now we solve 1 and 2. We can find the estimate of the parameters, that the alpha, which is equals to 2.78, and the estimate of theta, which is equals to 11884.40.
Okay, so very clear. Once you have this expected for the first row moment, second row moment. Okay, so substitute the formula. You just solve the simultaneous equation. You will get the answer. Okay, so please don't tell me that you don't know how to solve this first and second equation. Okay, it's very easy. You take 2 divided by 1, you will have equation 3. You take 2 divided by 1, you left only theta and alpha minus 2. Okay, that is a third equation. So third equation solved again with the equation 1, then this problem solved. Okay, so it's very easy. Now, we move to next question, number 3. Number 3.
A study is performed of time from submission of a claim on a life insurance policy until payment. For the 15 claims in the study, the time in days is as follows. That is given this data of the time in days. Using this data, the cumulative hazard rate at time 15 days, that is H15, is estimated with two estimations. That is, the H1 at 15 is the Nelson-Allen estimator, and the H2 15 is the method of moment estimator if the data are fit to a single parameter Pareto with parameter theta is 10. Determine the absolute value of the difference of H1 and H2 at 15. So we let X as the claims random variable, and first of all we have to calculate the cumulative hazard rate at 15 for the H1 under Nelson-Allen estimator. Next, by using the method of moment, we try to estimate the cumulative hazard rate at 15 for the H2 under single parameter Pareto with this data is 10, and from here we can estimate the alpha, and from the value of this estimate of alpha we can find the value of this H2 at 15, and hence this problem solved. Solution for question number 3. Let X be the random variable that representing the mortality data. Let Xi be unique, uncensored, and ascending value of random variable X. Let Ni be the number of Xi. Let Nxi be the number of X such that X is strictly less than Xi. And let Ri be the risk set. Then we have the following chart. So we try to place the data inside to the chart. And since the question is focused on 15, therefore we can arrange the 17 onwards as a group. So we have this result. And now we try to calculate the condition frequency for the Xi. If we choose our X1 as 11, so how many X is less than 11? So altogether we have 15. And if we choose the X2 as 12, so how many X value is strictly less than 12? That is, we have 13. And so on, we will have 12, 9, 7, 6. Since the question is without any deductible and also censored value, therefore, this frequency is equal to the risk set value. Thus, under this Nelson-Allen, the cumulative hazard rate at 15. And so we have to look at the last row at 15. That is, we try to consider all the reset from 15 until 7. So we will have 2 over 15 and plus 1 over 13 plus until 1 over 7. So this will give the result, which is about 0.825336. Now, let X be the loss random variable such that X is single parameter Pareto with the parameters alpha and theta is 10. So from table C, we will get the first row moment, which is this result, and in terms of alpha. So from the sample moment, we can calculate the first row moment. That is, we try to sum up all the theta, that is 11 plus 12 plus 13 plus until 131 and divided by 15. So we will have 344 divided by 15. And obviously, this will be equal to this. Then we will have 10 alpha divided by alpha minus 1, which is equals to 344 divided by 15. Therefore, alpha is equals to 172 divided by 97. So, under this single parameter Pareto distribution, we can find the survival at 15. That is equals to 10 over 15 to the power of alpha, which is 172 over 97. And this will give the cumulative hazard rate at 15 under single parameter Pareto, we name it H2, and this will be equals to negative log survival, that is 10 over 15 to the power of 172 over 97, and this will give me 0.71897. Hence, the absolute value of this which is equals to this result and minus this. So I will have 8.825336 minus 0.71897. So I will have 0.106367.
Okay, so for this question, you have two sections. So the first section, you have to use the Nelson-Allen to calculate the H15. So this one, you have no problem. You learned in chapter 2. Okay, so once you have done this, then you have to go to the second section. That is to find the H15 again, but using the method of moment. Okay, so because the parameters theta is given, so we need only one equation to find the alpha. That means you only involve the first row moment. Okay, so first row moment will give you the alpha, then this problem solved because we can find the survival, and then after that we can get the H value. Then we solve the problem by taking the difference. Okay, so this is quite simple. Let's go to question number 4.
Number 4, you are given the following. First, losses on a certain warranty product in year I follow a log normal distribution with parameters mu I and sigma I. Second, sigma I is equal to sigma for I is 1, 2, and 3. Now we let xi be the loss random variable, which is a log normal distributed with these parameters in year I, where the sigma I is a constant, which is sigma for the year 1, 2, and 3. Third, the parameters mu I vary in such a way that there is an annual inflation rate of 10% for losses. It means that for year 1, year 2, and year 3, there is an annual inflation rate of 10%. Means that the x2 random variable, which is equals to 1.1, that is 10% inflation rate of the x1 random variable. And similarly, in year 3, the x3, which is equals to, which is affected at 10% from the x2 in year 2. And next, the following is a sample of 7 losses. So this is the data from year 1 and this is data from year 2. Using trended losses, determine the method of movement estimate of mu3. That means this is referred to year 3. So based on the information given above here, we have to estimate the mu3 of year 3 by method of moments. Solution for number 4. Let xi be the loss random variable such that xi is log normal distributed with the parameters mu I and sigma, where the sigma is constant for these 3 years, which is corresponding to the year I for I is 1, 2, and 3. Since the losses inflated at 10% annually, therefore, x2 is equals to 1.1 x1 and x3 is equals to 1.1 x2. Then we have the following chart. So the question is given that the first year we have data of 20, 40, and 50. So when x1 is 20, then the x2 is equals to 1.1 and multiply the 20, so we will have 22. And similarly, 1.1 multiply 40, we will have 44. And 1.1 multiply 50, we will have 55. In year 2, is given the another 4 data. So we will have 30, 40, 90, and 120. So in year 3, this x3 is inflated by 10% of the x2. So we will have 1.1 multiply 22. So we will have 24.2. And next we will have 1.1 of x2, that is multiply 44. We will have 48.4. And similarly for this is 1.1 multiply 55, you will have 60.5. And this is similarly that 1.1 multiply 30, so we will have 33. And so on, you will have 44, 99, and 132. When you take 1.1 multiply this x2 data, then you will have this. In year 3, we consider x3 is log normal distributed with the parameters of mu3 and sigma. Then from table C, we will have the first row moment and the second row moments in terms of mu and sigma. Next. But the sample moment will give the first row moment is an average of the samples from the year 3. That is, we try to sum up all this data and divide it by 7. So we will have 1/7, 24.2 plus 48.4 plus until 132. So you will have 63.014. Similarly, for the second row moment, that we can find sum of square of all this data and divided by 7. That is 24.2 square plus 48.4 square plus 132 square, and we will have 5252.64. So next we try to compare this result, which is this figure. So we will have the exponential of this mu3 plus 0.5 sigma square, which is equal to 63.014. And similarly, this second row moment will be equal to this. So we will have this result. So let's say this is my first and second equation. So we solve 1 and 2. We will have the estimate of mu3, which is equal to 4.0035.
Okay, so this question number 4 is similar to number 5. You must you must calculate all the data in year 3. Okay, because the question asks to find what is the parameters in year 3, right? So you have to calculate all. Then after that, you go to the moment, okay, to calculate. Since you have the data, it means you can calculate the first row moment and also the second row moment. Okay, substitute these two inside here, the form the first row moment, second row moment, and then you can solve the simultaneous equation. Okay, so you will get the answer. Now to solve this 1 and 2, there's many ways to solve. You can take log, okay, or you expand it, right? You expand it, you divide, then you can get the answer. Up to you. So it's quite elementary. It's just a form 4, form 5 work. Okay. So we have done question number 4. Number 5 we have gone through yesterday. Okay. So now we go to question number 6.
Number 6, you fit losses to a Pareto using the method of moments, matching on the first 2 moments. The sample mean is 500. For what value of the empirical variance will a fit to a Pareto be possible? So we let X be the loss random variable, which is Pareto distributed with the parameter alpha and theta. And from here, we can find the expected value of X in terms of alpha and theta, and also the second row moment in terms of alpha and theta. And similarly, from the sample moments, which is given that the mean, which is 500, and this will be equal to this. And we could find the second row moment as well. And this will be matched with this. So by the informations, we have to find what is the possible value of this empirical variance. 6. Solution for number 6. Let x be the loss random variable such that x is Pareto distributed with the parameters alpha and theta. And from table C, we can have the first row moment and the second row moments in terms of alpha and theta. And from the sample moment, we will have the first row moment, that is the expected value of x, which is equal to the summation of xi divided by n. And this is given by 500. So obviously this is equal to this and will give this result. Similarly, we will have the second row moment, which is equal to summation of xi squared divided by n. And this will be equal to this, and we substitute our theta inside here, so we will have 2 times the theta square, that is a 500 multiply alpha minus 1 square, and divided by alpha minus 1 times alpha minus 2. So we simplify this, we will have 5 times 10 to the power of 5 times alpha minus 1 and divided by alpha minus 2. Then the empirical variance, which is given by this, and this is equals to the second row moment minus the first row moment square. And this result we have found, that is this. And this result is given, which is 500 square. Next, we try to rearrange this empirical variance as plus 500 divided by 5 times 10 to the power of 5, which is equals to alpha minus 1 divided by alpha minus 2. Now, assuming alpha is greater than 2, then this ratio is always greater than 1, and hence this is greater than 1. Therefore, this result this empirical variance plus 500 and divided by 5 times 10 to the power of 5, which is always greater than 1. And rearrange this again, then we will have this empirical variance, which is always greater than 5 times 10 to the power of 5 minus 500, and this is equals to 500 square. So therefore, we can conclude that the empirical variance now should take at least 500 square to fit a Pareto.
Okay, so question number 6 and number 7 is quite mathematical. So the question actually is asked to find what is the value should the variance of data taken. Okay, so you have, of course, the first row moment, second row moment you have to calculate. Okay, and this one is re-given the value. Okay, which is the 500. That is here. Okay, is given the now. The next is you can see after that you substitute your data, your alpha into here or into here. Then you will get the in terms of alpha for the second row moment. Okay. Now you can, after this, you rearrange this variance in terms of the second row moment minus the first row moment square, and later you substitute inside, then you can see something. Okay. Now from here you try to rearrange in terms of alpha minus 1 divided by alpha minus 2. Okay. So the whole thing just now, this variance. Okay, this variance. Okay, you rearrange in term, just leave it until alpha minus 1 divided by alpha minus 2. So from here, very obvious that the alpha must be greater than 2. Although the question didn't mention, but understood. If alpha is less than 2, this becomes negative. That is not meaningless. That is meaningless. If alpha is 2, it's undefined, right? So the alpha must be more than 2 so that this is always positive. Okay, so in other words here, once your alpha is greater than 2, then this is always greater than 1. This ratio is always greater than 1. Then the whole thing means that the whole thing is greater than 1. Then from there, you can solve the problem, right? If this whole thing is greater than 1, then I can see what is the lower bound of this variance. This is a variance formula, okay? So the lower bound actually is a 500 square. That means the minimum is a 500 square to fit the Pareto distribution. Okay, so it's question number 6 and 7 quite mathematical. Okay, so we have done this 5 question. The other group also here up to here. So we left only one question 13. I have to discuss together with all of you. Eh? So today is only this. Okay. Do you have any questions? So if no question, you may leave now. Okay. I will post the information about the quiz. That is not next week. It's after next week. Okay. And only topic 2. Okay. So that's it. Now, if you have not filled up the survey of this subject, please do it. Today is the last day, I think. Okay.